Good day. Welcome to Regular Shivers Educational Limited, presenting Royal Tutors, your trusted support for brain-friendly, high-impact learning. Today, we'll be continuing from where we stopped in our AQA GCSE Physics Paper review. And so far, we've been on paper 1 topics. We've talked about energy, electricity, and today we're moving on to the third topic, which says particle model of matter. Do have it at the back of your mind that after reviewing this topic, we also look at some past questions in line with AQA exam board that align with this topic. This topic explores how matter is made up of tiny particles and how their arrangements and movement affect properties like density, temperature, state of matters, and pressure. You will learn how to calculate density, explain changes of state, understand the role of internal energy, apply formulas for heat capacity and latent heat, and describe how gases behave under different conditions as well. Density. Density tells us how much mass is packed into a certain volume. The formula for density, we have letter P equals to M divided by V. The M there stands for mass, the V there stands for volume, and that letter P stands for density. It's important to take note of the unit of these parameters so that you'll be able to identify them in any questions. In solid and liquids, particles are close together, so densities are similar. Liquids are often less dense than solid, but there are exceptions. For example, ice is less dense than water, so it floats. Gases have particles far apart, making them much less dense. If volume increases while mass stays the same, density decreases because the particles are more spread out. Changes of state. Matter can change between solid, liquid, and gas, but the mass remains constant throughout this process. Physical changes only affect the arrangement and movement of particles, not their chemical identity. We have some process when it has to do with changes of state: melting when it changes from solid to liquid, freezing when it changes from liquid to solid, evaporating or boiling when it changes from liquid to gas, condensing when it changes from gas to liquid, and sublimation when it moves from solid to gas without becoming a liquid. And it's important for you to also take note of examples of some changes that undergoes this process. These changes can be reversed, and when reversed, the substance regains its original properties. Internal energy. All particles in a material have stored energy called internal energy. And this is made up of kinetic energy, which is due to the motion or vibration of particles, potential energy stored in the forces between particles. Heating a substance increases the energy of its particles, which can raise the temperature, making particles move faster, cause a change of state without a temperature change, breaking or forming particle bonds. Specific heat capacity. The specific heat capacity is the amount of energy needed to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. And the formula we use is change in thermal energy equals to mass times the specific capacity times the change in temperature. You can see the parameters being outlined right there. A substance with high temperature requires more energy to heat up and also cools down more slowly. This concept explains why water is used in heating systems and why metals heat up quickly. Specific latent heat. Specific latent heat is the energy required to change the state of 1 kilogram of a substance without changing its temperature. And we have the formula there. The change in the energy is equal to mass times the specific latent heat. And we have what we call the latent heat of fusion. Latent heat of fusion is the energy required to melt or freeze, while latent heat of evaporation is the energy to boil or condense. And during a change of state, energy is absorbed during melting and evaporation. Energy is released during freezing and condensation. Sublimation is when a solid changes into gas, as with dry ice. I've mentioned this earlier on during the course of the session. Heating and cooling. When a substance is heated or cooled, the temperature increases until a change of state starts. During melting or boiling, temperature stays constant during the energy is being because the energy is being used to break particle bonds rather than increasing movement. Melting usually takes less energy than boiling because vaporization requires more bonds to be broken. Gas pressure basics. Gas particles moves in random direction at high speed. Temperature is linked to the average kinetic energy of these particles. Higher temperature move to faster moving particles, which results in more frequent and forceful collisions with container walls, which result in higher pressure. So pressure is the total force from this collision per unit area of the container walls. Pressure and volume. If temperature is constant, then we have the formula P1V1 equals to P2V2. The initial pressure multiplied by the initial volume equals to final pressure multiplied by final volume. Increasing volume means that particles have more space and collide less often, which causes the pressure to decrease. Decreasing volumes means particles collide more often, which leads to pressure increasing. This relationship explains why a balloon expands as it rises to lower pressure areas. Increasing gas pressure. Adding more gas to a fixed volume increases the number of particles, which results into more collisions and higher pressure. Compressing gas into a smaller volume forces particles closer together, increasing collision frequency and pressure. If compression is fast, particles gain energy, increasing the gas temperature and pressure further. When walls of the container move inward during compression, particles rebound faster, increasing their momentum and kinetic energy. In conclusion, the particle model of matter describes how particle arrangement and movement determine the properties of solids, liquids, and gases. It links density to mass and volume, shows that mass is conserved in state exchanges, and explains how heating affects temperature or state through specific heat capacity and latent heat. In gases, temperature, pressure, and volume are connected, helping us understand and predict many physical phenomena. So we are going to now move forward into review of some past questions in line with the topic particle model of matter.
All right, we'll be continuing from where we stopped by taking a look at some relative questions in particle model of matter. The first question here says that a student investigates the three states of matter. The arrangement of particles in these three states of matter are different. We are to draw one line from each particle arrangement to the state of matter. We are to draw one line from each particle arrangement to the state of matter. So it's important that we know the way the particles are being arranged for us to be able to identify the actual state of matter in each one of them. Take a look at the particle arrangement and take a look at the state of matter. So from the picture we are seeing right here, it gives us an insight into the actual state of matter that each of them belongs to. If you look at the first one, you will see that they are closely packed together. And when the particles are closely packed together, we say that such is a solid. Okay? And whenever they are loosely packed together, okay, we say they are gas. Okay? And then we have the last one there. Is also loosely packed, but not like gas. That is what we call liquid. Then the next question says that a large sum of ice was heated and changed states. The figure below shows how the temperatures varied with time. Which part of the figure below shows when the ice starts melting? When the ice starts melting, the answer would be the figure, the letter B, because at letter A is still at freezing point, but at letter B, that is when the ice starts melting from. Then moving forward to the next question now, it says that which part of the figure above shows when the water was boiling? The answer is going to be, let's take a look at the picture again. That would be letter D. letter D. If you treat it like 100 degrees Celsius, that is when the water is considered to be boiling. Okay, then we move on again to the next question. It says, which property of the water particles changes as the temperature of the water increases? That has to do with the kinetic energy of the particles. Initially, the water particles, they are at a resting stage, but when it's being subjected to temperature, you see that the water particles start moving. So that is why we say the kinetic energy of the particles will start, because the kinetic energy of the particles will change as the temperature of the water increases. Then the next question is just in alignment with what we also treated under specific latency. They say we calculate the thermal energy needed to melt 0.250 kilogram of ice at 0 degrees Celsius, and they have given us the standard value for the specific latency coefficient of water. So all you just need to do is to put the value, your thermal energy, equals to your mass, which is already in kilogram, okay, multiplied by your specific latent heat value that has been given to you. Okay, and then you get your answer in joules because you're talking about thermal energy, and that will give you 83,500 joules. All right, let's move on to the next question. So in the next question, it says we should complete the sentence, we should choose the answer from the box. It says a substance is heated and changes directly from solid to a gas. Remember, we talked about this. When a substance changes directly from solid to gas without having to pass through the liquid state, we say that it's sublime. So the substance sublimates. That's what we say. The substance sublimates. All right, let's move on to the next question, number 2. He said we should describe how the student wanted to determine the density of a small piece of rock. Describe how the student could measure the volume of a piece of rock. This should be how many markers now? This is like 4 markers. So you need to come down to describe it appropriately. This is just about the density. It's very simple. The first thing you want to do is that you want to measure. You fill your cylinder with water. So you want to measure the initial volume of the water. So let's say the initial volume of the water initially, like let's say 20 cm cube. Then when you drop the rock inside the water, they now measure the final volume of the water, which can be, let's say, 50 centimeter cube. So what do? You now compare the initial volume to the final volume. The initial volume to the final volume to determine the displacement, and that will give you the actual volume of the piece of the rock. In this case now, it's going to be 30 cm cube when we find the difference. That is how the student can actually carry out that particular experiment. All right, let's go to the next question. So the volume of the piece of rock was 18 cm cube, maybe after the experiment. And I said that the student measured the mass of the rock as 48.6 grams. Calculate the density of the rock in gram per cm cube. You already have the formula given to you, and the mass is 48.6. So that will be 48.6 gram divided by the volume, which is 18 cm cube. So if you divide that, that will give you 2.70 gram per cm cube as your answer. 2.70 gram per cm cube as your answer. It's as simple as that. So they say the graph below shows the density of different types of rock. We can see different types of rocks and their density. They say, what is the most likely type of rock that the student had? What is the most likely type of rock that the student had? We're talking about rock. Limestone is a rock. Others that we have here, they are just a stone. Even sandstone will have been considered, but you see that limestone is even more than sandstone. But basalt, that's even higher, is not a rock. So the most likely type of rock that student will have is going to be a limestone. Then quickly, let's look at the next question there. They say that we should give one sources of error that may have occurred when the student measured the volume of the rock. One major mistake that probably they will have is maybe when they are taking a look at the measurement of the water through the cylinder. The high position while they are reading the measurement in the cylinder can be one of the errors that might occur during the experiment. Okay, then the last question there says, how would the error you describe in part D affect how would the error you describe in part D affect the measured volume of the rock? How would the error you described in part D affect the measured volume of the rock? You see, if the error is not being prevented, it's going to affect the volume of the rock, because if you did not get the measurement correctly, it's going to affect the final volume of the rock that is being measured. It's going to affect the final volume of the rock that is being measured. So that is one of the way in which the error that is being described that I talk about, taking the measurement through the cylinder, how it can affect the measurement of the volume of the rock in the whole process. All right, so I'm going to stop here for today. Thank you so much for following through. In our next class, we're going to be looking at the last particular topic we're expected to cover in preparation for paper 1 of AQA Physics GCSE exam. And that particular topic is what we are going to look at in our next class, which has to do with atomic structure. And when we are done with that, then we'll now proceed forward to look at some topics we are also expected to cover in paper 2 of AQA exam board. Thank you so much for following through. Do well to subscribe for more. Bye.